So you know the denominator. So say if I draw like a bunch of squares right now, and I shade one in. So the denominator represents all the squares. So that will be all the, so if this is our group, the denominator represents all the squares, while the numerator suggests the ones that you're focusing on. So say we're focusing on the shaded one, the numerator would be the shaded squares. That makes sense? So say in this case, how many squares do we have altogether?
4.
Yeah, that's good. So that will be 4 squares in total. So that will be the denominator, or the squares. And then how many are shaded? How many squares are shaded?
1.
Yeah, 1. So that 1 represents the shaded squares, which would be the numerator. So that's telling us that 1 out of 4 of the squares here are shaded. So basically 1 out of 4, also known as a quarter, of the squares are shaded. Does that make sense?
Yeah.
That's good. So if I go up here to do more examples, now we have circles. And we want to work out what fraction of the shape is shaded. So if we focus on the first circle, sorry. First, you can work out the denominator. So you remember the denominator is everything in total. So we say all the parts in this circle in total. How many would there be?
8.
That's good, 8. And how many are shaded?
3.
Yes, good, that'll be 3. So that means 3 out of 8 of this shape is shaded. So that's good. And now if you try it with the next circle, what would you say the fraction of it being shaded is?
1 out of 3.
That's good, 1/3, and that's also known as a third. That's correct. And then the last one.
2 out of 4. A half.
Yeah, did you say 2 out of 4?
Yeah.
Yeah, that's good. So there's 4 sections in total, and 2 of them are shaded, which is good. So 2/4 is also known as 2/4. So 2/4. Does that make sense in how we've simplified that?
Yeah.
That's good. So hopefully finding out the shaded shapes makes more sense. And obviously that's something that we can keep referring back to. And as I said before, fractions is a big topic. So there's lots to do with fractions. So next on the list be simplified fractions here. So have you heard of simplifying fractions and how that works?
Yeah.
That's good. So if I gave you a fraction here, do you feel like you'll be able to try and simplify that? Or should we work through it together?
I can simplify it.
Yeah, so what would this simplify down to?
1/2.
Yeah, that's good, that's correct. So half. And if I give you more examples so we can do practice. What about 2/8?
1/4.
That's good, a quarter. If I say 4/12.
A third.
That's good, a third. And then if you do one more example. 6/18.
A third.
Yeah, that would also be a third as well. That's good. I can see that you're really good at simplifying fractions. I'm glad that you got that quickly, as well as working out the fractions of shaded areas. And now we can go on to adding and subtracting. So is that mainly what you focus on when someone mentions fractions?
Well, I don't know. I've not done much of fractions because every time we did fractions at my school, it went into lockdown.
Ah, okay, that's fine, no worries. So we can go through it together now. We'll just do like a brief example on it. So say if I make up a question and say 1/4 plus 2/4. So this you didn't get a chance to do in school?
We did some of it, but we didn't do like, I don't know. We didn't do all of it.
You didn't do very complicated,
Yeah.
did you? So you did simple ones.
So with this question, do you feel like it's something that you can answer?
Yeah.
So what would this be?
3/4.
3/4, yeah, that's correct. And if I give you another example. So 3/8 plus 2/8. What would this be?
5/8.
Yeah, that's good. So that would be 5/8. So that's correct. So it's good that you know these ones, and where fractions might get a little bit confusing is when the denominators have different numbers. So say if we have 1/2 plus 1/4. So have you seen questions like this? Yeah, that's fine. So with this, there's one extra step that we need to do in order to be able to add it properly. So you know that you can only add fractions when the denominator, so the bottom number, is the same. So what we want to do is find a common multiple in the 2 times tables and in the 4 times tables. So a number that's both in the 2 times tables and the 4 times tables.
8.
Yeah, that's good. So 8. So let's say that we want to make our denominator 8 for both of those fractions. So to the first fraction, 1/2, what would we need to multiply 2 by in order to get 8?
4.
That's good, times by 4. So that means we times the numerator, the top number, by 4 as well. So if we do 1 times 4, what does that give us?
4.
That's good, 4. And now with the second fraction, 1/4, what would we need to multiply 4 by in order to get 8?
2.
Times by 2. So that means we also times the numerator, so the top number, by 2 as well. So if we do 1 times 2, what does that give us?
2.
2, that's good. And then now you can see that we have 2 fractions with the same denominator. And what we've done here is that 1/2, is equivalent, so equals the same thing as 4/8. So we haven't actually changed the fraction, but we've just made it easier to help us add it. Does that make sense?
Yeah.
That's good. And now if we try to add that, what would you think the answer is?
6/8.
6/8. Yeah, that's correct. So how did you find that question?
Well, I don't know.
Easy, you're going to say easy.
Yeah, that's good. So it's good to have confidence in the work that you do. And obviously we can do much more practice on this and like with different numbers, and hopefully that improves your confidence. I'm glad that you found it good and you did really good this session. Like I can see that you're confident in like all the sections that we've done. So it's basically just more practice to get more used to it.